Good day, everyone. I welcome you back into today's tutorial. What we're going to be focusing today will be understanding TCP/IP. So when we're talking about TCP/IP, what does TCP stand from? TCP stands from a transmission control protocol, and the IP stands from an internet protocol. So when we're talking about this TCP/IP, the two protocol works together, and the function of these two protocol is a set of a communication protocol used to interconnect network device in a private computer network as well as the internet. So basically, when we're talking about this TCP/IP, the function of TCP/IP, they are the one that monitor anything connection, both on when we are talking about internet and when we're talking about a LAN. So they are the suite of a communication protocol. They are just like a rules. They are just like a rules that we use to connect network devices in a private computer network and also on the internet. So let me break the function of a TCP/IP for you. So imagine we have a two system on the network. The first system want to send a document to the second system. What TCP is going to do is that TCP is going to break down the document down into what we call a packet. When TCP break it down, the function of IP is to make sure that the document move from the first system into the second system. So TCP/IP, the both protocol, they work together for them to be able to achieve their goals on what you're talking about on the network. So when we have a TCP without IP, it's just like when we have a mobile phone without SIM card. So when we have a mobile phone without SIM card, the mobile phone is going to be useless. And when we have a IP without TCP, it's just like when we have a SIM card without a mobile phone. So when we have a SIM card without a mobile phone as well, the SIM card is going to be useless. So these two protocols, they work together in order to achieve their goals. So here says that TCP/IP stand from a transmission control protocol, where IP stand from an internet protocol. These are the suite of a communication protocol used to interconnect network device in a private computer network as well as on the internet. So when we're talking about this particular TCP/IP, this TCP/IP has two versions. The first version is a TCP/IP version 4, and the second version is a TCP/IP version 6. So those are the two versions that TCP/IP has. The first version here is a TCP/IP version 4, and the second version is a TCP/IP version 6. So when we're talking about this TCP/IP, TCP/IP was developed by the US Department of Defense, which is what we call DoD. So this TCP/IP was developed by the US Department of Defense, and what this they use it to specify how computer transfer data from one device to another. So if any one system want to transfer a data to another system on a network, TCP/IP will be the one to know how the data is going to move from one system to another. So when we're talking about TCP/IP on a network, TCP/IP is very, very important. So when we're talking about this TCP/IP, TCP, what's the function of a TCP? Here says that TCP manage how a message is assembled into smaller packets before they are then transmitted over the internet and reassemble it in the right order at the destination address. So like what I explained to you, when we have two devices on a network and one devices want to send a document to the second devices, the function of TCP is that then TCP is going to assemble the document into what we call a smaller packet. It's going to assemble it. For instance, maybe I want to send a file of 50 MB. If a system wants to send a file of 50 MB to the second system, what TCP is going to do is that TCP is going to break that 50 MB into 10 MB, so that we're going to have like 5 different packets, like 10 MB. When TCP break it down, the function of IP is to carry that particular document from the first system into the second system. Once the document now gets to the destination, the function of TCP will still be the one to do what? It will still be the one to reassemble it back. Because TCP is the one that assemble it into smaller packets, and it will be the one to reassemble it into normal document before he assemble it into smaller packets. So that's the function of a TCP on the network. TCP manage how a message is assembled into smaller packets before they are then transmitted over the internet and reassemble it in the right order at the destination address. But when we're talking about IP, they say why IP define how to address and route each packet to make sure it reach the right destination. So the function of TCP is to break the packet down, and the function of IP is to carry the packet and make sure that the packet gets to the right destination. So here it now says that each computer on the network check this IP address to determine where to forward the message to. So when we're talking about this IP address is very, very important on the network. Before a single system can communicate to another system on the network, what they use to do it is what we call an IP address. For instance, imagine I want to send a goods to another location. Maybe I'm giving a dispatch rider the goods. Before the dispatch rider can know where exactly I want him to deliver the goods, I must give the dispatch rider the street and the number of the address that is going to. So that dispatch rider with the street name and the number address is going to know where exactly to deliver that particular goods to. So that's the main function of what IP address is doing on the network, so that we're going to know the legit destination that we are heading to. So when we're now talking about this IP address, here says that an IP address, which stands from an internet protocol address, this is a series of number that we assign to each device connected to a computer network or the internet. So basically, when we're talking about this IP address is the same thing like a human name. You know, anytime that we give birth to a child, we're going to give the child a name. The same thing with the IP address. So when we have a devices on the network, all those devices, they're going to have their own IP address that they assign to each of them. So that's the reason why here says that an IP address is a series of number that we assign to each device connected on a computer network or the internet. So when you're talking about this IP address, here says that IP addresses identify and differentiate the billions of online devices, including computers and mobile phone. So all our system on the network, they make use of an IP address, including your mobile phone. Before your mobile phone can be browsed, your mobile phone has what we call IP address. And if your mobile phone doesn't have IP address, there's no way you'll be able to communicate over the internet. And here says that an IP address identify and differentiate the billions of online devices, including computer and a mobile phone, and help those devices to communicate with one another. So the main function of an IP address is to make them to communicate and let us to know where we're going to send our packet to at the right destination. So when we're talking about this IP address, we have some other devices that are connected to the internet, including printer. Printer make use of what we call an IP address, and growing number of Internet of Things device like a smart speaker. We have nowadays, we have a lot of IoT, a lot of Internet of Things nowadays. For example, like a smart speaker, we have refrigerators, we have a home surveillance system and more. So all those stuff here, they make use of what we call an IP address. So when we're now talking about this IP address, here is an example of a various device connected to the same network. So here is an example of an IP address. Here you're going to see the first IP address. Here is a 172.16.254.1. So anytime you are hearing about 172.16.254.1, that is what an IP address is. So but here is their network. Their network is a 172.16.254.0. So anytime you are seeing anything dot zero is a network. Network is different from an IP address. So network is the one that gave birth to IP address. So inside the network, that is where we're going to see a lot of an IP address. So here, the IP address that we have here, the first one here is a 172.16.254.1. The second one is a 172.16.254.2. The third is a 172.16.254.3. Default is a 172.16.254.4 go to 5. So here is an example of what IP address looks like. But when we're talking about this IP address, every system on the network has their own unique IP address. So when we have a system that is using 172.16.254.1, there is no other system that can be using this particular IP address, which means that each devices on the network is going to have their own unique IP address on the network. There must not be what we call a duplicate address on the network. So the next thing here is why do we need IP address? Here says computer need IP address to communicate with other online devices and the network. The purpose of IP address is to map the web and send data to the right place. So for instance, let's assume that I bring up my system and I want to browse to Facebook. How is my system going to know that I'm going to Facebook? Is through the IP address of Facebook. So that's when my system going to know that, yeah, I'm heading to Facebook. So that's the importance of the IP address on the network. If we don't have IP address on the network, there is no way I will be able to communicate to another online devices. So here is an example of all the online devices or online websites that make use of a IP address. First one here is a Facebook. Facebook has its own unique IP. Before you can browse to Facebook, you need the IP address of Facebook. The second one here is a email. Before you can check your email, you need IP address. The third one here is a web browser. Before you can able to use a web browser and you browse the internet, you make use of what we call an IP address. So when we're talking about this IP address, we have different types of IP address. The first one here is a public IP and the second is a private and IP address. So when we're talking about a public IP address, here says that a public IP address, which is also called external or global IP address, is used to communicate between hosts. Host is what they call the devices. So anytime you are talking about a host, is any devices that we can assign IP address to. So here says that a public IP address, which is also called external or global IP address, is used to communicate between hosts and the global internet. Public IP address are provided by ISP, which is what we call Internet Service Provider. So anytime we are talking about the IP address, what I want you to put in mind is that public IP address is any IP address that can take us to the internet. So any IP address that we use to browse the internet, those are what we call a public IP address. And this public IP address, we can't determine it by ourselves. We can't decide it by ourselves. It's given to us by the internet service provider. And those are who are the internet service provider. Example is the MTN, Airtel, Glo, Etisalat. Those are what they call an ISP, which means that before you can have a public IP address, you must either have a MTN SIM card or you are using Glo, Airtel, or Etisalat. Those are the ISP that will be giving you that particular public IP address before you can be able to browse the internet. So the second type of a IP is what we call a private IP address. So when we're talking about a private IP address, here says that a private IP address, often called a local or internal IP address, is assigned to your devices from within a private network. Private IP address are not routed on the internet and are intended to work only within your local network. So basically, when we're talking about a private IP address are the IP address that they cannot take you to the internet. Those are the IP address that we can actually be using on our private network. There's no way the IP address that can take us to the publicly and people will be seeing us. All those private IP address are the IP address that we can use within our LAN, which means that it can't take us to the internet. And when we are talking about public IP, those are the IP address that can take us to the internet, the IP address that we can use publicly. And those IP address is given to us by ISP. But when we're talking about a private IP address, These private IP address are the IP address that they cannot take us to the internet. Those IP address are only working in our private network. So the next thing now says that how IP address and assign. So maybe you have a public IP or you have a private IP. How do you give your system IP? How can we assign IP to a system? You can assign IP to system in two ways. The first one here is a static and the second is a dynamic. Those are the two ways that you can assign IP to a system. The first one is a static IP and the second is a dynamic IP. So when we're talking about a static IP address is an IP address that we manually configure on a device by the network administrator. So basically, when we're talking about a static IP means that you as a network administrator, you will be the one to manually configure the IP on the devices. You will be the one to enter the devices and you'll be the one to give the devices any IP address that you want to use. Here now says that when a device is assigned a static IP, the address won't change over time, which can help some online service work more smoothly. So anytime we give a device IP in a static way, that particular IP address is not going to change. That will be what the device is going to be using until you go there and change it to something else. So basically, when we're talking about static IP address, that is when you are giving a system IP address in a manual way, which means that you will be the one to go to the system and assign the IP address by yourself. And that particular IP address is not going to change. So the second way here is a dynamic IP. So when we're talking about a dynamic IP address is an IP address that is automatically assigned to a device on the network by what we call DHCP, which stands from a dynamic host configuration protocol, which means that when we are talking about a dynamic IP is a automatically way and a static IP is a manual way. So inside this dynamic IP, there must be what we call a DHCP server, which we're going to be issue all those IP address out automatically. So here, a network administrator don't need to be going to each devices and be giving them IP by himself. What will be giving those IP address out, that is what we call a DHCP, which is a dynamic host configuration protocol. So when we're talking about this dynamic IP address, here says that a dynamic IP address can change when it needs to, such as when a device is connecting to a new network. So what I want you to put in mind is that anytime you are configuring a dynamic IP address usually change because when you are configuring a dynamic IP, there's what we call a lease time. Lease time means that the expiry date that the IP is going to change. So for instance, let's assume that I'm configuring a dynamic IP and I configure the lease time as a 24-hour. What does that one mean is that when the DHCP server issue the IP address to the devices is only going to make use of that IP for 24 hours. Once the IP reach 24 hours, the DHCP server is going to collect the IP address back and the devices still need to do another request. The devices still need to request for another IP. So when the devices is still requesting for another IP, in that scenario, the IP can change. So that's the reason why we say that when we're talking about static IP is a static IP and the IP address won't change. But when we're talking about a dynamic IP address usually change when the time need to. So here, when we're now talking about this static and a dynamic, in which scenario do we need a static IP and in which scenario do we need a dynamic and IP? So when we're talking about static, for instance, if I want to give a system, maybe I'm a network administrator on a company and they only have like 10 system, I can actually use a static IP. I will be going to each system and I will be giving them the IP by myself. But the scenario that we need a DHCP, imagine that you are working for a company and they have like thousands of employees For you to be going from one system to another is going to be giving you tough time. So you can use a DHCP to achieve that goals in that scenario. So here now says that how can we check IP on our system? So how can we check your IP address on our system? The first thing you need to do is that you need to come to your CMD. Once you come to your search bar, come to your search bar and you type CMD, which stands from a command prompt. So when the CMD come up, what you need to type here is a ncpa.cpl and hit enter key. So when you type ncpa.cpl and hit enter key, you will come to Ethernet. Anything that you are using to connect is either you are using Wi-Fi or you are using Ethernet. Come to double click on anything you are using to connect and click the one that says TCP IP v4. Double click. Here it says that obtain an IP address automatically, which means that I want to make use of a DHCP. Second one says that use the following IP, which means that you want to configure a static way. So that is a way you can assign IP address to your system. Is either you are using static, which is the second option, or you are using DHCP, which is the first option. So let's now assume that I want to check my IP address. If you want to check your IP address, once you come to your CMD, just type ipconfig, which stands from Internet Protocol Configuration, and hit enter key. Once you hit enter key, here is going to show you what your IP address is. Here it says that I'm using 192.168.0.251. That is my IP address. So that's how you can change your IP address on the network. So the next thing we want to talk about here is the classes of a IPv4 address. Classes of a IPv4 address. So when we're talking about this IPv4 address, we have from class A to class E. So class A ranges of IPv4 address is from 1 to 126. Those are the classes. And this class A IPv4 address can only contain number of hosts of 16,777,000. Those are the how many hosts can we give a class A IP address. So in which usage do we use this class A? They make use of this class A IP address in a large network. And the default subnet mask of a class A IP address is a 255.0.0.0, which is also what we call /8. So when we're talking about this class A, who are those people that make use of a class A IP address? Those people that make use of class A IP address is when we're talking about ISP, which are the internet service provider. They are the one that make use of a class A IP address, because you can't imagine how many people MTN are giving network per day. So all those people, they are the one that are using a large network. But when we're talking about this class B IP address start from this number, which is a 128 to 191. That is the range that class B IP address started from. And how many devices can we assign class B IP address to? We can only assign class B IP address to 65,534 devices. So here now says that what are the usage of class B? Class B IP address is used in a medium network. And here is the default subnet mask of a class B IP address, which is 255.255.0.0, which is also what we call as a /16. So the next one here is a class C. Class C IP address starts from the range of 192.225 192 to 223. Class C IP address starts from 192 to 223. And the number of hosts means that how many devices can we assign class C IP address to? We can only assign class C IP address to 254 devices. And the function of this class C is used in a small network. And this class C has a default subnet mask, which is a 255.255.255.0, which is what we call a /24. So this /24 is equivalent to this particular subnet /16 is the same thing with this, and /8 is the same thing with this. So when we're talking about class D and E, class D and E, they are used for what we call a broadcast transmission and a scientific research. So those class of IP address, we don't use to assign it to a system. Those IP address are using for what we call a research. But here, out of all this range, there is a particular number that they omitted here, which is a 127. So I'm still going to explain the function of that 127 for you when we are moving further. So here it says that a subnet mask tells a computer, here now we have a subnet mask here. So what are the function of this subnet mask? And before I move ahead, here it says that 255.0.0.0 or /8. How do they get this /8 here? When you do a binary for 255, you're going to see 1 in 8 places. That is how they derive an /8. So when you do the binary for 255 here, you're going to see 8 here. Do binary of 255, you see another 8. 8 plus 8, that was 16. So how did they get 24 here? 8 plus 8 plus 8, that will give you /24. So all these subnet masks we are seeing here, what are the function of the subnet mask? So here now says that a subnet mask tell a computer or other network device what portion of IP address is used to represent the network and what part is used to represent the host or other computer on the network. So the function of this subnet mask is to tell the computer what part of this subnet mask did they use to represent the host and what part did they use to represent the network. That's the function of a subnet mask on the network. On the network. So the next thing here is that particular number that they omitted here, because here start from 1 to 126 and here start from 128. They omitted 127. So what's the function of that 127? Here says that 127.0.0.0 is a loop back test. So that is the function of the particular IP address. 127.0.0.0 is a loopback subnet. The IP address 127.0.0.1 is called a loopback address, and packets sent to this address never reach the network but are looped through the network interface card, which is LAN adapter only. So basically, the function of this loopback address is just to use to is just to use to diagnostic purpose to verify that the internal path through the TCP IP protocol is working. So the particular address is just used to check maybe your NIC card is working and your internet protocol and your TCP, everything is working properly. So that's the function of that particular IP. We use it for checking. We can't assign it to a devices. So the next thing here is a RFC 1918 address. Those addresses are what we call private IPv4 addresses. These addresses are what we call a private IPv4 addresses. So what is the full form of a RFC? Here start from a request for comments. Those are the full form of RFC. These body are the one that they give us a private IP address that we can be using on our network. So this body now come up say, hey, inside class A IP address, any network that start from 10.0.0 to 10.255.255.255, anybody can make use of it within the LAN. So which means that you can use it freely. ISP shouldn't be the one to be giving you this IP. Anytime you want to create a LAN, you can make use of this particular IP address. And now say that in class B, any IP that starts from 172.16.0.0 to 172.31.255.255, you can use it freely. And they say in class C as well, any IP started from 192.168.0.0 to 192.168.255.255, you can make use of it freely. So these IP addresses are only used for internal communication, which means that you can only make use of this IP address on your LAN and are not allowed on the internet. This IP address are not allowed on the internet. You can only make use for internal communication. And all ISPs are to block these addresses from getting to the internet, which means that this body make a law that this particular IP address should be used within a LAN. And they now say that they should block this particular IP from getting to the internet. So that's the reason why anytime you are making use of a private IPv4 address, there's no way the address can take you to the internet because they have already blocked all those address from getting to the internet. So the next thing here is a APIPA, which stands from a automatic private internet protocol address. That is the full meaning of a APIPA, automatic private internet protocol address. So what's the function of this APIPA? But this APIPA is a class B IP address, and the ranges of this APIPA start from 169.254.0.1 to 169.254.255.254. So any IP address coming from these ranges, those are what we call the APIPA IP address. So what are these APIPA IP address? Here says that APIPA is a feature in a OS, which is an operating system such as a Windows, that enable computer to automatically self-configure an IP address and subnet mask when their DHCP server is not reachable. So anytime we configure a DHCP on the network, which is a dynamic host configuration protocol, if there's any issue with the DHCP or the DHCP is not reachable, and if any system is requesting for any IP address on the network and their DHCP server is not reachable, the system is going to self-configure itself an IP. So the IP address that the system configure itself that time, those are what we call the APIPA, which is a automatic private internet protocol address. So APIPA is when a system self-configure itself with an IP address when there is an issue with DHCP server. So the next thing we're going to be focusing on here now is a TCP IP layers. That's the next thing we're going to be focusing on, TCP IP layer. So basically, we all know what TCP IP is, and you know the function of it on the network. TCP IP, we stand from a transmission control protocol, and the IP stand from an internet protocol. So these two bodies work together just to achieve their goals when we're talking about on network. So this TCP IP has four layers. It has four layers. This layer is numbered from down to top. So I want you to put it in mind anytime they ask you what is the first layer of a TCP IP. Don't go there and say it is an application layer. No, that is error. Application layer is the last layer of a TCP IP. So this thing is mentioned from down to top. So the first layer of a TCP IP is a network access layer. The second layer is a internet layer, and the third layer is a transport layer, where the last layer is a application layer. So when we're talking about this network layer, which is the first layer here, so what's the function of this network layer? Here says that TCP IP network access layer, this guy combine layer 1 and layer 2 of the OSI model. So you're still going to understand this particular OSI model. But this particular layer 1 of TCP IP is a combination of a layer 1 and layer 2 of a OSI model. Here now says that network access layer handle the physical infrastructure that lets computer communicate with one another over the LAN or internet. This cover Ethernet cables, wireless network, network interface card, device driver in your computer, and so on. So basically, when we're talking about a network access layer, this network access layer are the physical infrastructure that lets a devices to communicate on the network. So imagine something that can make a devices to communicate on a network, the physical infrastructure, those are what we call a network access layer. It can be your Ethernet cable. before two devices can communicate on a network, there must be a cable that is connecting them together. Those cables falls under what we call a network access layer. It can be a wireless. When devices communicating on wireless, there must be what we call a wireless router there. There must be wireless router. All those wireless router dey falls inside what we call a network access card, a network access layer, I mean. So it can be your network interface card or device driver. So network access layer are the one that handle any physical infrastructure that lets computers to communicate with one another. So the second one here is a internet layer. So when we're talking about internet layer, here says that internet layer, which is also known as a network layer in a OSI model. So what is the function of this internet layer? Internet layer control the flow and routing of traffic to ensure data is sent speedily and accurately. This layer is also responsible for reassembling the data packet at its destination. So the main function of this internet layer is the one that control the flow of routing of traffic, and it ensure that the data sent from one devices to another move speedily and accurately. So imagine now here now, if I send you a message on WhatsApp, I can't send you a message on WhatsApp by this time and you will be getting the message on by 4 or 5. No. Internet layer will make sure that the message I sent you immediately gets to you immediately and everything move to you speedily and accurately. That's the function of the internet layer. And the function of this internet layer, it will still be the one to reassemble the data when the data gets to the destination. That is the function of what internet layer does on the TCP IP. So the third one here is a transport layer. So when we're talking about this transport layer, here says that the transport layer provide a reliable data connection between two communication device. A transport layer is one that provide a reliable data connection between two communicating device. So when we have a computer A that is communicating to computer B, a transport layer is one that going to bring what we call a reliable connection in between the two devices, so that anything that computer A is sending to computer B is going to be getting everything. It's not maybe computer A will be sending a file and half of the file will be missing. So a transport layer will be the one to bring what we call a reliable data connection in between the two devices. Here it says that the transport layer is going to divide the data in packets, acknowledges the packet it has received by the sender, and ensure that the recipient acknowledges the packet it received. So what's the function of a transport layer? Imagine we have two devices on the network that they are communicating. If device A is sending a file of 5 gig to device B, transport layer will be the one to divide that 5 gig into what we call smaller packets. We're going to divide that 5 gig into smaller packets, and when the 5 gig into smaller packet get to the device B, the transport layer will still be the one to acknowledge maybe the device B get the document, maybe e get exactly that particular 5 gig. So if the device D now get this, the device B will still going to do what? It will acknowledge back to the device A that yes, I get the document in full. But if there's any missing out of the document, the device A is still going to send it back. So what are the layers that are responsible for that one is what we call a transport layer. Transport layer makes sure that everything I send to you exactly gets to you and none of it miss along the way. So the next thing here is the application layer, which is the last layer of a TCP IP. Application layer here says that in TCP IP application layer combine layer 5, layer 6, and layer 7 of the OSI model. This application layer is the group of application that let the users access the network. For instance now, if I want to send you a message on Gmail, before you can get the message, you must have a Gmail application. So that all those applications, they falls under application layer of a TCP IP. So before I can send you any message on Facebook, or I'm sending you on a WhatsApp, or I'm sending you on a Skype, you must already have the particular browser website application. So if I'm sending you a message on Facebook, you need to go and download a Facebook application on your system before you can interact with the message. So all those things falls under application layer. But before the message can come to application layer, it has already passed through a lot of layer before it can come to the last layer. Here now says that the application layer is the group of applications that let the user access the network. For most of us, that means email. We you make use of a Gmail. Anytime I want to send email out, I will make use of a Gmail app, or I use Yahoo Mail or messaging app like a Skype and Zoom. So all those things are what falls under application layer. So this is what the end user see and interact with when sending and receiving data. But before I send you a message and you see the message in your application layer, the message have passed through network access layer down to internet layer to transport before you can now see it in a application layer. So the next thing we're going to be talking about here is a OSI model. So when we're talking about OSI model stands from Open System Interconnection Model. So what's the function of this model? OSI is the reference model developed by the ISO. If you can remember, I explained to you that TCP/IP is developed by the US Department of Defense, which is DoD. But when we're talking about this OSI is developed by ISO, which is an international standard organization. So what's the function of this OSI model? This is used to allow network device manufactured by different vendors to intercommunicate. When there is no OSI model, there is no way different vendors of devices can communicate. For instance, if you have a devices that is made by HP and we have another devices that is made by Mac, they won't be able to communicate. But the function of OSI model is to enable a different devices that is produced by different vendors to be able to communicate. So here now says that before the OSI model, there was a vendor lock-in, which means that different vendors cannot communicate to themselves on the network. Here says that the OSI model has 7 layers, number from bottom to top. So when we're talking about this OSI model and TCP/IP, TCP/IP and OSI model, they are doing the same thing. OSI model is the one that they combine together to give us a TCP. So some layers in OSI model, they combine them together for us to get what we call a TCP/IP. When we're talking about this OSI model layer has like 7 layers, and this layer here is numbered from down to top. Remember, when we are doing the TCP/IP here, I explained to you that TCP/IP model layers is numbered from what? From down to top. So anytime anybody asks you what is the second layer of TCP/IP, you need to know that it is a internet layer, not transport layer. If you are saying transport layer, that is the error, because transport layer is the third layer of a TCP/IP. So put it in mind, the layer is numbered from down to top. So when we're talking about this OSI model layer, it has 7 layers, and those layers are numbered from down to top. So the first layer of the OSI model is a physical layer. The second layer is a data link. Third layer is a network layer. Fourth layer is a transport. Next layer is a session. Sixth layer is a presentation. And the last layer of the OSI model is a application layer. So like what I explained to you earlier, OSI model, they combine some layers in OSI models to give us the TCP/IP layers. So when we're talking about this physical layer, we have already talked about physical layer when we're talking about TCP. Physical layer is the one that handle all the physical infrastructure before the two devices can communicate on the network. And here says that a physical layer is a physical structure. For example, coax. When we're talking about a coaxial cable, those are the physical device, the physical hardware that devices can use to connect before they can communicate on the network, or a fiber cable, or a wireless hub and repeater. So all those devices dey fall under what we call a physical layer of OSI model. The next one here is the data link. This data link here is going to convert that packet into frame. Data link is going to send a frame, and this frame here, the devices will make use inside this data link is Ethernet, PPP, switch, bridge. So all those things are the something that can give a host to host connection, what can connect a multiple hosts together. Those are what that falls under a data link. It can be your switch when we are using a switch and all the devices are connected to the switch. It can be a bridge, it can be PPP, it can be Ethernet. All those things they fall under what we call a data link. So the third layer, which is a network layer, this network layer is what we call as the packet. We'll talk about packets. So what are the protocol that works under a network layer? We have IP, which is an internet protocol. So IP works under network layer. We have ICMP, it works under network layer. We have IPsec, it works under network layer, and we have IGMP. So all these protocol, they are the one that works under a network layer. So the number fourth layer here is a transport layer. Transport layer here is one that produce a end-to-end connection. It produce end-to-end connection, and we have two protocol that works inside the transport layer. The first one here is a TCP, and the second is a UDP. So TCP stands from a transmission control protocol, and the UDP stands from a user datagram protocol. So what is the difference between TCP and the UDP? TCP is the one that gives us a reliable connection. So when we have two devices connected on a network with TCP, they're going to be what we call a reliable data connection. But when we're talking about a UDP, UDP doesn't give us a reliable data connection. So UDP is not reliable, but UDP is faster. But when we're talking about TCP, TCP is reliable, but TCP is slower. So in which scenario can we use TCP and UDP? Anytime you want to send a file and I want to make sure that the file I'm sending out and you get all the file, I will be making use of a TCP. But anytime I want to be playing online gaming or I want to be streaming something online that I need a faster connection, I will be making use of a UDP, because UDP is very, very faster, but UDP is not reliable. But when we're talking about TCP, TCP is reliable, but it is not faster. So anytime I want to send you a document, I want to send you a file, and I want to make sure that you get the file, and I want to make sure you get exactly document I'm sending, I will be making use of a TCP. But in any time that I don't need, maybe I don't need you to get, I don't need a story, I don't need you to get a reliable, I don't need you to get what I'm sending. I only, in a scenario that I only need a faster connection. Anytime I need a faster connection, I will be making use of a UDP just to do anything I want to do. But anything you need a reliable connection, you'll be using TCP. So the second one here is a session, and this session is what we call sync and is sent to port. So all the protocol that work under this session are API, socket, and a wink socks. So the third one here is a presentation. So what's the function of this session? Imagine that I want to log into a Facebook. Anytime I want to log into Facebook, Facebook is going to ask me for my username and my password. So anytime I put my username and I put my password and I log in, there will be a session. The session will be the session will be up. But anytime that I log out from that Facebook, the session is disconnected. The session will be aborted. But anytime you connect to the Facebook, there will be session will be created. So when we're talking about this presentation, This presentation is how the message is going to be present on your system. Is how the message that the first devices is sending out, how is the message going to be looking out on your system. So we have different protocol that is working under presentation. We have SSL, SSH, IMAP, FTP, MPEG, and JPEG. So if I'm sending you a image now, if I'm sending image to you, how the image going to present on your system? You will be seeing JPEG or you are seeing MPG. So that's how you're going to see and you say, okay, this is the image. If I'm sending you a music, sometimes you will be seeing MP3, you will be seeing MP4. So that's how the thing is going to present on your system and you're going to know what type of message is. So the last one here is the application, which is the last layer of a OSI model. So application layers is the one that now give a user the ability to be able to interact with the message that we are sending out. So here it says that application is the end user's layer, and we have a lot of protocol that is working in an application layer. The first one here is the HTTP. So HTTP work in a application layer, but you know that nowadays we have a strong version of a HTTP, which we know as a HTTPX. So that is the strong version of a HTTP. We have FTP, IRC, SSH, and a DNS. So all these application, all these protocol, they are the one that works under application layer. So if I come back to this TCP, here says that this network access layer is the combination of a layer 1 and layer 2 of OSI model. So this network access, they are the one that they use to connect, they combine physical and data link of OSI before it can give us a network access layer in a TCP. What about this second one, this internet layer? This internet layer is also what they call the network layer of a OSI model. That internet layer is also what they call the network layer. And the third layer, which is transport. This transport here is also transport in a OSI model. But the last layer of a TCP, which is a application, this application layer is the combination of a layer 5, layer 6, and layer 7 of a OSI model. So what I want you to put in mind is that OSI model and TCP, they do the same thing. OSI model and TCP, they are the same thing. But when you're talking about OSI model, they combine some layers in OSI model to give us some layers in the application in a TCP IP. They combine some layers in OSI model to give us some layer in a TCP IP. Which means that before a two devices can communicate on the network, that communication needs to pass through this layer before the second devices can now see it. So if I send you a message through Gmail, the message will first go to a physical layer. From physical, goes to data link, goes to network, goes to transport, goes to session, goes to presentation, and then that's when you now be able to see the message on your application. And that's where you now be able to respond to wherever I'm sending. So before a single sender can send a message to a receiver, the message is going to pass through these particular layers. So here is the both layers when we have a TCP and we have a OSI model. So here, as you already know that TCP IP has 4 layers and the OSI model has 7 layers. So OSI model layers is number from down to top. OSI model layer is number from down to top. So the first layer of OSI model is a physical layer. The second layer is a data link. The third layer is a network layer. The fourth layer is a transport. The fifth layer is a session. Sixth is a presentation. And the last layer is a application. So the combination of layer 1 and layer 2 of OSI model give us network layer in a TCP IP. So network layer is also a network layer here. Transport layer is also a transport layer. But the combination of a session, which is layer 5, presentation, which is layer 6, and application, which is layer 7 of OSI model is the one that give us application in a TCP IP. So all these layer, you need to put them in mind and you need to know how the layer is arranged. Make sure that you know that the layer is arranged from down to top, not top to down. So that is all about a TCP IP. That is everything that we need to know about TCP IP. So I want you to put it in mind that we have classes of IPv4 address, which is a class A to class E. But that class D and E, we are not using it on system. They are meant for scientific and multicast transmission research. But the IP that we use on system is A and C. So put it in mind, the IP we use on system is A and C. And we have two type of IP address. We have public and private. And how we can assign IP address, we can assign it in a static way or we assign it in a dynamic way. So here are everything that we need to know about the TCP IP. So with what we have been explaining so far, do we have any question? So do we have any question?
Can you hear me, please?
Yeah, I'm hearing you.
Okay. Um, Under the OSI model, I think
Yes.
uh, maybe you can just go there. Yes, under the network layer, that's the
Okay.
third layer. We talked about the packets, which, of course, like we explained from the beginning. For example, documents are broken down, the format with which data are transmitted on the network using the TC.
I'm not hearing you clearly, please.
Okay, can you hear me now?
I'm hearing you, but speak louder, please.
Okay, okay. What I'm saying is, under the OSI model,
Yes.
the third layer, which is the network,
Network, yeah.
you have you have packets, right?
Yes.
And these packets are the form data are transmitted over the network. They are
Yes.
broken down. Now you mentioned IP, ICMP, IPsec, and then GMP. I need you to just elaborate a little on them.
Oh,
I know IP is the internet protocol.
okay, let
The
me
ICMP and the rest. Just explain a little.
okay, let me explain what those things is doing. When we're talking about a network layer, are you hearing me?
Yes, I can hear you.
Okay. When we're talking about network layer is the one that going to make sure that that packet move from one place to another. So here now says that the packet, the data, any data that we are sending, network layer will be the one to change that data into packets. So when we now change it to packets, what's the function of IP here? IP is an internet protocol, which is the one that will carry the packet from one place to another. And it will be the one to make sure that the packet gets to the right destination. So this ICMP is another protocol that we use to share connectivity on the network. This time from a internet control messaging protocol. So anytime I want to ping, maybe we have two devices on the network. If the two devices want to share, maybe they are connected together, they need to ping each other by pinging their IP address. So anytime they are pinging each other, the protocol they are using there is what we call an ICMP. ICMP is the word that work is the protocol work for pinging. So the next one here is the IPsec. IPsec as well is the internet protocol security. That is what we use to secure IP address. So IPsec, anything we are sending from one place to another, there must be something that will be securing it. Example is what we call a VPN. So imagine we have two devices that they are sending data from one device to another, and that data is in a plain text. A bad guy, it is easy for a bad guy to hijack that particular data. But with this IP security, we're going to secure that particular data by making use of what we call a VPN. So VPN will be the one to secure that data moving from one end to another. But the protocol word there is a IPsec. And we have an IGMP as well. All these particular protocol, they are just the protocol that work for when we are transporting a data from one place to another. And if you want to check a connection on the network. Hello,
Okay. Thank you. Thank you. I got them now.
is there any question again?
No.
So if there's no question, that will be the end of the class because that's what we want to cover for this class. So if there's any question, let me know before I end the class.
Sorry. I don't know. Can I go ahead?
Yeah, I'm hearing you.
This presentation, is it possible? Is it going to be one of the lecture materials for us?
Which one?
The presentation you just made now, the document.
Yeah, you
Is
guys
it
can
possible?
have it, but you guys are doing like what I hear. You guys are doing AWS, right?
Yes.
If you guys are doing AWS, you need to know all this IP address. So you guys still going to have this particular slide in case you can go home
Okay.
and go through it again.
Okay.
Yes.
Thank you.
Okay. So if there's no question, so we're going to stop here for today. So let's have a great day.